All right, there's a pretty good chance that you've been drawing raindrops wrong your entire life. And I say that because I was making a mudslide video the other day and I was using almost this whiteboard tool where I was drawing raindrops. And I looked back at it and I realized I've been drawing them wrong as well. So most people draw a very teardrop shaped raindrop, but it turns out that is not what raindrops actually look like. So to find out what they actually do look like, we're going to read this article and also to understand the science behind what's actually going on. So just looking at it, why raindrops aren't shaped the way you'd think. We commonly imagine raindrops to be tear-shaped, but the actual shape of raindrops is not what we would expect. To understand why, we need to look at the physical properties of water and air, as well as the forces that act upon falling raindrops. So this is a perfect example of one of those scientific questions where it seems very simple, but then there's actually some interesting science behind it that isn't exactly difficult to understand, but it illustrates and illuminates what's actually going on kind of behind the scenes. So raindrop formation. Raindrops form when water vapor condenses into tiny droplets, which then grow in size and eventually coalesce into a single drop. So this happens usually in a cloud. You have all these little droplets that have gone from water vapor, they condense, turn into little liquid droplets, and then as they bump into each other, they get bigger and bigger, and then as they get big enough, they become heavy enough that gravity pulls them down, and that's when you get an actual falling drop. So as the droplets fall, they are subjected to a variety of forces, including gravity, which I just named, but then also air resistance and surface tension. So gravity, that's the one that probably makes the most sense right off the bat. Gravity is the force that pulls the droplet downward, accelerating it as it falls. Air resistance is the force that slows the droplet down, decreasing its velocity until it reaches its terminal velocity. Surface tension is the force that causes the droplet to form a spherical shape. So gravity is the force that's pulling the droplet down. Air resistance you can almost think of it as the force that's keeping the droplet up a little bit. And then another way to think of air resistance, I don't know if this is a perfect example, but when you put your hand outside the car on the highway, you feel your hand kind of blowing back like this. I believe that's because of air resistance. For example, if you were to do that in space, you could be going very fast and your hand wouldn't be blowing back. So you'd also probably have bigger problems. But yeah, believe that's air resistance. You can kind of think of the droplet having that effect on it as it falls. And then surface tension, that probably gets into like electrons and protons and neutrons and maybe even chemistry. So we're not going to go there, but you can imagine it's just what's keeping all those water droplets together and then is also creating the spherical shape that it has. So now let's get into the shape of droplets. So why are droplets not tear-shaped as we often imagine? The answer lies in the aerodynamic forces acting on the droplet as it falls. As the droplet accelerates, air resistance causes the droplet to become deformed, and the droplet's center of gravity shifts. This shift in the center of gravity causes the droplet to become asymmetrical and take on a more flattened shape. So when you have a very small droplet, like less than, I forget the exact number, I think it might be 2 millimeters, that's when surface tension is greater than any of the other forces, so your droplet's going to be very circular or spherical. And then as the droplet gets larger, it's going to be falling faster. So then some of that gravity and air resistance starts to kind of overpower just your surface tension, and it's going to flatten out the bottom of your droplet, almost so it looks like a hamburger bun. And then what's very interesting is as this gets strong enough, or your droplet gets large enough, I believe it's 5 millimeters, that's when it turns into a full-on parachute. And you've maybe seen this at one point. I noticed it at the beach the other day where waves were crashing into this rock and I'd see them go up, and then as they'd start to fall, it almost looked like the water was popping. And what's happening there is you start off with a droplet, but then it almost fills up with air and becomes, literally it looks like a parachute. And then the top of it just pops like that. And then it becomes lots of different droplets. So that's kind of what's going on there. Let's just continue reading. The surface tension of the water also plays a role in the shape of the raindrop. As the droplet falls, the surface tension of the water prevents the droplet from becoming completely deformed, causing it to retain its spherical shape to some degree. So that's why it goes from very spherical when it's very small to almost like a hamburger bun as it gets bigger. So because of the surface tension still keeping it together, but then once it gets big enough and it's falling fast enough, turns into a parachute and pops. So conclusion, although we often imagine raindrops to be tear-shaped, the actual shape of raindrops is determined by a variety of physical forces. Gravity, air resistance, and surface tension all play a role in the formation and shape of raindrops, causing them to take on a more flattened shape. So it's the three forces, and then I'd say the three different shapes that we have. When the droplet's very small, it's mostly surface tension, just keeping that droplet very spherical. As it gets a little bit bigger, that's when your gravity and your air resistance start to flatten out the bottom. Mostly your air resistance starts to flatten out the bottom, looks like a hamburger bun, and then eventually it turns into a parachute, pops, and then you have lots of little droplets that'll probably go through the exact same process. So hopefully this video is interesting. I actually learned a little making this video as well. So for more weather content, I'll keep making these every single day, Monday through Friday, and thanks for watching.